Alright, in this video we're going to look at the derivative of functions that are composed. And to do that, we need to learn what's called the chain rule, which is a really important differentiation technique. And it'll basically allow us to take the derivative of any function I put on the page. You should be able to take the derivative of it once you know the chain rule, along with all the other derivatives, the derivative of sine, cosine, e to the x, all the other analytic functions that you know and you've learned. So just as a review, let's remind ourselves what function composition means. If capital F of x is equal to square root of x squared plus 1, I could interpret that as the composite of two functions. I could say that that if lowercase f of x is equal to the square root of x and g of x is equal to x squared plus 1, then we're just saying that capital F of x is equal to f, lowercase f, of g of x. Alright, and you can check that just knowing what you know about function composition. The question is, how do you take the derivative? How do you take the derivative of this, of a composite function? Because if we had a rule or a formula for the derivative of a composite function, that'll help us take the derivative of functions that kind of look complicated. And so it turns out that it's a nice just multiplication that you end up having to do. And so let's explore why that might, or let's at least explore, or to get an intuition as to why that would make sense with a diagram. So I could view function composition as starting with an input x, feeding it into a function g. So notice that's how it works, right? You start from the inside function and work your way out. So that produces g of x. And then you input g of x into f, lowercase f, and you get f of g of x. And there's a diagram that sort of indicates how function composition works. Now let's talk about rates of change. If I wanted the derivative of g of x, if I just viewed the left half of this diagram, well then I could say the rate of change of g at x, we just use the notation g prime of x, right? So that's not new. Let's go to the right arm. What's the rate of change of f? The rate of change of f at g of x, remember g of x is its input, rate of f, rate of change of f, the rate of change of f. Well, that's just going to be f prime of g of x. And so I've got the derivative of g at x, I've got the derivative of f at g of x. The question is, what is the derivative of f of g of x? So what we want to know is, what is the derivative of f of g of x? Well, it turns out it's just the derivative of g at its input, x, times the derivative of f at its input, g of x. And that's the chain rule. That's the chain rule. It's just the product of the two derivatives, f and g. Now, this is kind of an informal introduction, and we really need to kind of explore, at least in the next video when we introduce the second notation. We want to introduce why is it multiplication? Why are you just timesing those two derivatives? And a quick intuitive example I think would help that make sense. But for now, let's just take it on faith. Often you'll notice g prime was written first. What often happens when you see the chain rule is that the right part, f prime of g of x, is written first. But in this video, let's just take it on faith and apply this. So let's use our example above here. I've got that capital F of x is equal to the composite of f, lowercase f of g of x. So f prime of x is going to be the derivative of f of g of x, which equals, according to the chain rule up here, g prime of x times f prime of g of x. And as long as we get those derivatives down in the page, we'll have our final answer. So let's go calculate those derivatives. So I know that f of x is root x. So if f of x is root x, that means that f prime of x is, so by the way, root x is the same as x to the 1/2. So I'm going to write it like that so I can use the power rule. 1/2 x to the negative 1/2, which we could write as 1 over 2 root x. And g prime of x, which we'll also need for this formula, is just 2x. And so now if I just plug those into my chain rule here, I get that g prime of x is 2x. And f prime of g of x is, well, it's 1 over 2 root, now I don't have an input of g of x, I have an input of g of x. So 1 over 2 root g of x, which is just 2x times 1 over 2 square root of, and g of x is x squared plus 1. Alright, and there it is, there's the chain rule. There's the derivative of that function. The thing to point out, and the thing we'll revisit in the next few videos, is that function composition is often viewed in terms of an inside and an outside function. And so what we've basically done is we've taken the derivative of the inside, so I'm going to say derivative of inside, times the derivative of the outside. Alright, the other thing to notice is that we're basically finding the derivative of the outside, the chain rule is basically allowing us to find the derivative of the outside function f at the interior input x. And it turns out that it's just the product of the inside derivative at x times the outside derivative at g of x in this case. But we'll explore this more in the next video.